Treat this property, normal models for discrete data. So far we've looked at normal distributions that model continuous data. Okay, normal models can also represent discrete data. If the data is large, then the data will fall into the symmetric unimodal. Remember, this is like one mode. Okay, bell shape, and therefore we can use the normal model to make predictions. So let's take a look at an example of that. A company produces boxes of candy-coated peanuts. Okay. The number of pieces in each box is assumed to be normally distributed, so that's good. Okay, with a mean of 48 pieces, so let's go mean equals 48, and like per box, and a standard deviation is of 4.3 pieces. In order to keep the customer satisfied while not losing money by overfilling boxes, they must reject boxes fewer than 44 pieces. So X is less than 44 is a reject. Okay, but then boxes more than 55 pieces will cost, when X is greater than 55, it'll cost too much money. Again, they need to reject that. So if the customer is not getting many pieces per box, then the customer is going to be unsatisfied. But then if they're getting too many, maybe the customers are going to be satisfied, but the company is going to lose money. Let's do, what is the probability that a box selected at random contains exactly 50 pieces? So here's the thing. When we do a question like A, we have the normal distribution and the mean right in the middle, which is 48. Here's the problem. There is a theorem that says if it's exactly 50, the probability of there being exactly 50 pieces in the box is actually 0. So what we have to do is we have to gap for discrete data. We have to gap to 49.5, and we have to gap on that side to 50.5. So it has to contain at least enough area under this curve in order for us to find a probability. So basically what we're finding is the probability that X is between 49.5 and 50.5. Okay? So for a question like this, what we want to do is we want to find the probability of, let's go, X is less than 50.5. And then we want to subtract the probability that X is that 49.5. X is greater than 49.5. Okay, so let's do these two individually. We're going to look for the z-score. So we're going to look for X minus mu over sigma, and then minus X minus mu over sigma, but for the 50.5 and the 49.5. So X, we have 50.5 minus the average, which is 48, over 4.3. And then we have subtract 49.5 minus 48 over 4.3. And if we put these into our calculators, 50.5 minus 48 divided by 4.3, I get 0.58, but that's our z-score. And then 49.5 minus 48 divided by 4.3, I get 0.35. Okay, do not subtract these. These are our z-scores. Let's put a z beside them. Okay, so we need to look up the z-score of 0.58 and then the z-score of 0.35. So for 0.58, and these both are positive, so that's fine. 0.5 is here, and then 0, 1, 2, 3, 4, 5, 6, 7, 8. 7190, so that's good. So there's a probability of 71.9%. And then we're going to look up 0.35. 0.3 is here, 0, 1, 2, 3, 4, 5, 6, 3, 6, 8. Okay, 63.68. Now let's actually subtract those. 71.9 minus 63.68. We get a probability of 8.22. So there is an 8.22% that you will get exactly 50 pieces. Probability that x equals 50 equals 8.22%. Okay, now what percent of the production will be rejected as a result of containing too few pieces? Okay, so we're going to reject less than 44 or greater than 55. Let's go to the next page. Okay, so I just moved everything up and I cleared the screen here. So what we want to do is we want to know the probability that x is less than 44, because all of those are going to be rejected. And then we want to know the probability that x is greater than 55, because we're also going to reject that as well. Okay, something to keep in mind when we do the normal distribution and we find these probabilities, the probability, whatever the number is here, is the probability from the left tail, so this left tail here, all the way to that number. Okay, so we're actually going to have to do it a little bit backward for the second one, so just pay attention to that. Okay. So equals, let's go x minus mu over sigma plus, so for this one, what's going to happen is we have to reject greater than 55. So this is actually what the bell curve is going to look like. It's going to look like this. So the average right here in the middle is 48. We want to reject all of this, which is 44. And that's fine because it goes from the left tail all the way to 44. Now, we also want to reject 55 and above. So for this one, we actually have to take 100% or 1 as the probability and subtract from 55 and below. So this is actually going to be 1 minus x minus mu over sigma. Okay, so for this one, we're going to go x, which is 44 minus 48 over 4.3. And then we're going to also reject 1 minus 55 minus 48 over 4.3. And remember, whenever we sub in these numbers to this formula, we're actually only finding the z-score. Okay, so the first z-score is, and I'll put z-score, negative 0.93. Okay, and the second z-score is 50 minus 48 divided by 4.3, 1.6, we'll round up to 3. So negative 0.93, let's look that up. It's going to be on the negative side of everything. Negative 0.9 is here. 0, 1, 2, 3. 1762. So the first one is a probability of 1762. And then we're going to do 1 minus z-score of 1.63. So move this back over. We're going to do 1.6, which is here. And then we're going to go, this will be 0, 1, 2, 3, 9484. We'll actually do the decimal here. Okay, so we have 1762, and then we'll do like 100 minus 9484, or you can do 1 minus 0.9484, and we get the probability of 5.16. So when we add these two together, we get a total probability of 22.78. So there's a 22.78% chance it will be rejected. Okay, too many chocolates in the box, too few chocolate in the boxes. And go to the next video and we will do C and D.